So I just want to remind you that if you want a paper copy of these notes, they're on Google Classroom and you can print them and put the notes on here, or you can just copy these things down on your own. So a little flashback from Friday. We were talking about absolute value. And when we were talking about absolute value, you have, let's change it from yellow. You have absolute value of x means distance. So when we see something inside absolute value bars, we know that we're referring to the distance of something. And if it's a variable, we're talking about some number that we're not sure about. Well, now we're going to combine that with inequalities. So when you see something that says, what does absolute value of x greater than 4 really mean? That means we're talking about when the distance is bigger than 4. The distance some number is from 0 has to be bigger than 4. Well, what kinds of distance are bigger than 4? Well, we would talk about 4.1, 5, all the way up till forever at infinity. But what we're not talking about is the 4 itself. Likewise, since we're doing absolute value and we're counting steps, if I start at -4 and I go towards the negative infinity side of things, any of those numbers also have a distance from 0 that is bigger than 4. So this is what the graph of absolute value greater than 4 would look like. Similarly, if you have absolute value of some number less than 4, that means when the distance, and you can write this down on your own, when the distance from 0 is going to be less than 4. So if I think about that, the distance from 0 has to be less than 4 would be numbers like 1 and 2 and 3 and things really close to 4. Same as its reflective side on the negative aspect. Much like with the greater than, you cannot include the 4 and the -4. So you're talking about all these numbers. And again, if you test any of these numbers that are in that range, like absolute value of -1, if I test that, that has a distance of 1 from 0. So that is certainly going to be less than 4. And you can test any number in there. So if you're looking for a pattern, both of these two, whether it's the absolute value of x greater than 4 or the absolute value of x less than 4, these definitely look a lot like those graphs that we were dealing with in class on Thursday, just inequality graphs. So these look like a compound inequality. They look like compound inequalities joining two things. Now this one that we were just dealing with, this looks like an and inequality, a typical and inequality, because it has that bandwidth and stretches between two numbers. Whereas the x greater than 4 looks like an or inequality. Okay, so what you need to do as you're taking notes is you need to write yourself more notes than what I'm writing down. You need to write down the things that make sense to you, such as a less than is going to look like an and a greater than is going to look like an or. But all in all, absolute value combined with inequality means that we're going to be dealing with compound inequalities. So here's a little cheat sheet. When you have to solve these absolute value inequalities and it's a greater than, then you need to focus the fact that this is two things, okay? Let me point out to you that this one right here, this is greater than. It is an or inequality, but more so than that, focus also on this one, this first one, which is exactly the same, okay? So this is one that is exactly identifiable to what you had if you dropped the absolute value bars, okay? But the other one, you have two problems to create. The first problem is exactly the same. Then there's the second problem. And the second problem, if you pay attention to it, the difference between it and the first is that it has the sign change on the symbol and on the number that's on the opposite side. So for instance, if I had the example being like absolute value of 3x plus 1 is greater than 5. Then I would set up two problems. My first problem would just be 3x plus 1 greater than 5. Then I'm going to include the word or. And my second problem is going to be 3x plus 1 is going to be less than -5. And I would solve both of those, and because it's an or, I would just graph them and do my thing. Okay? Looking at the second one, when we have a less than situation. A less than situation is going to be an and, okay? Much like the last example I just showed you, the first case is going to be exactly the same, okay? So this one's the same as exactly what you have there. But the second one, you're going to similarly change the sign and the symbol. So if we look at an example of that, if I gave you the problem, absolute value of 2x minus 3 is less than or equal, and less than or equal are, exchangeable as far as this rule is concerned, less than or equal to 10. Then my first problem would be 2x minus 3 less than or equal to 10. And my second problem would be 2x minus 3 is greater than or equal to negative 10. Sorry if you can hear my dog. Okay. What you need to remember that's important is that if the original absolute value problem says greater than, then that's an or. And if the original absolute value problem is a less than problem, then think of it as a less than. Like we were doing when we were solving equations, the first thing that you have to do is divide by this 2, because you have to get it down to just the absolute value problem. So this truly is a problem, absolute value of x minus 4 greater than 4. And that's what we're going to split up into our two problems. So my first problem is going to be x minus 4 greater than 4. And again, because the original problem is a greater than, you're going to use an or when you set up your two problems. So now you have x minus 4 less than negative 4. And you can solve each one of those. So if I solve the first one, obviously I'm going to add my 4, and that's going to be x greater than 8. Or, and I solve the other one, add my 4, and I get x less than 0. So I need to graph both of these. So I have 0, 1, 2, and 8 here. So if I want to graph those, the first one's going to be open circle going to the right side, and then at 0, I'm going to have an open circle going towards negative infinity. Writing my answer in interval notation would give me parentheses, negative infinity to 0, closed with a parenthesis, united with or union 8 to positive infinity. And that would be my solution in my graph. Okay, so for the second problem, you need to move the negative 1 and the 4. So we're going to add our 1, which is going to give us 4 absolute value of quantity x plus 2. If I add 1, that gives me 12. And then I'm going to divide by my 4, and I get absolute value of x plus 2 is less than 3. And then this is what I'm going to split up into my two problems. So my first problem is going to be x plus 2 less than 3, and because this is a less than, I get an and here. And then x plus 2 greater than negative 3. Go ahead and solve each of those. If I subtract my 2, I get 1 here. And if I subtract my 2, I get x greater than negative 5 on this one. So when we graph negative 5, 4, 3, 2. Okay, so go ahead and label your graph. And this is an and situation, so I get my yellow and blue make green. So yellow is going to be from 1 towards negative infinity. Blue is going to be from negative 5 towards positive infinity. So my answer in red is going to be open circle at both of them, and then here in the middle, leaving me in interval notation with parentheses negative 5 to 1, close parentheses. And that's my solution. I want you to try this one on your own. So go ahead and hit pause, and when you've worked it out on your own, come back and I'll have worked through the steps. I'll show you the steps, and you can see if they match yours. Okay, so check the work, move your -3 and do all that stuff. I'm going to go ahead and graph it now. So -2, here's 0, and 6. So we would have the first one would be less than or equal to 6, and the second one would be greater than or equal to -2. So my final graph would be a closed dot and closed dot on both, and then color between them, leaving me bracket and -2. Oh, don't know what that just was. -2 to 6, both in brackets. Again, that's negative. This is another one I want you to try to practice on your own, and then hit pause and come back and check it. Okay, guys, so check this one out. Let me know if you have any issues. I simplified above where I broke down 1 and 2. I simplified and got the absolute value by itself. Solved each one of them. Remember that this is an and problem. Solved each one and saw where they overlap, and then recorded that in. Okay. There are a couple times when you have special cases. So if I look at this one, I know what happens is we get into like solve mode and mentality, but you have to also be in think mode too. Like, let's think about this. We know absolute value means distance, okay? So if this is distance here, you're saying when is the distance going to be less than -12? Well, you tell me, can you ever have a negative distance? So if you can't have a negative distance, when is your distance ever going to be less than a negative? Okay, so without doing any work, I can look at this and say this thing here isn't even possible. So why spend my time doing all this stuff only to find out they're never going to cross each other? Okay, if you wanted to solve, guess what you're going to do? You're going to solve and find out this won't work. That's going to be a no-go. Okay, or instead you can think about it right at the beginning and say, well, I know distance can't ever be negative. This can't happen, so there's going to be no solution. And honestly, guys, if you forget and you are in that mode to just solve, when you solve and you set this up as an and problem, you're going to look for where they overlap, and guess what's going to happen? They're not going to overlap. Okay, so save yourself the time, effort, and energy, and just look and evaluate the situation before you get started. Likewise, look at this one. Your red flag should go off when you start seeing negatives over here when it's by itself. Okay, so I already have my absolute value isolated, meaning there's nothing here in the front and here in the back. I don't have to worry about any of those things. So now I need to look at what I have, think about the situation right here. Can your distance ever be bigger than a negative? Well, when is your distance ever going to be bigger than a negative? Well, isn't that always going to be the case? So if it's always going to be bigger than a negative, again, don't save yourself from doing all this work here because that's ridiculous. When in actuality, you could save yourself doing this and say, that's unnecessary. This will always work. Therefore, I know this is always going to be all real numbers. I'll be real honest. Some of you are going to, no matter what I say and what I tell you, you're still going to solve them. And hopefully then you're going to realize it's an or problem where they overlap and you're going to have everything colored in. So that if you do all that work that I just said you don't have to do, you better get two graphs to overlap each other because your distance will always be bigger than a negative. Okay? Those last two are the special cases. Other than that, you guys are good to go. So when you come in on Monday, we're going to practice these things. Okay, so make sure you have your notes and have this all taken care of. Enjoy the rest of your weekend. You are done with math. See you guys Monday.